Describe sigma and pi bonds. Well, if we imagine two hydrogen atoms, you can see their s orbitals there. And when they react to form the molecule H2, they make a single covalent bond, which is called a sigma bond. All single bonds are sigma bonds. And all sigma bonds go along the internuclear axis. If you imagine a line that joins both nuclei, that's the direction the sigma bond will take. And if you have two fluorine atoms, when their p orbitals overlap just like this, that also forms a sigma bond, which is a single covalent bond. Now for hydrogen fluoride, HF, the s and the p orbitals for the H and the F respectively again form a sigma bond, single covalent bond, that goes along the internuclear axis. The final sigma bond creation you need to know is, for example, in methane, which is between hybrid orbitals and, in this case, hydrogen. Now that looks quite complicated, and there'll be more detail about that in further videos. So that's the sigma bonds dealt with. If you have two atoms with parallel p orbitals, and those p orbitals are brought close enough together to overlap, you're going to form a pi bond. So the top and the bottom lobes kind of mold into those blobs. Now those small donut shapes are where the nuclei would be. So it's parallel to the internuclear axis. The p orbitals initially were parallel to that internuclear axis, and that gives you a pi bond. Now if you have a sigma bond and a pi bond, you've just made a double bond. Now it looks like there's three bonds, but it really isn't. It's just a double bond. And for a triple bond, well, you're going to get in another pi bond at 90 degrees to the first one. So that's now a triple bond. It's kind of like a hot dog in a bun and then another bun put at the side. Oh, now I'm hungry.